Hello Internet! Today we have a very interesting repair of this Gigabyte card. That looks so nasty, I don't know if it came from a pig farm, or from hell, or from one of my viewers. In any case, let's take it apart and see if we find anything interesting inside. Once inside, I gotta say, I'm not gonna clean this one. I'm just gonna go straight into the measurements. Hopefully the problem is not near the dirty area. We have kiloohms on 12 volt, 3.3 with kiloohms, USB-C 14K, 1.8 volt 2 kiloohms, PEX 8 ohms. This one here is 3.3 volt, same as before. 12 volt here with kiloohms, and this 12 volt is the same. 5 volt here with 11 kiloohms. The rest is all 12 volt with several kiloohms as usual. Since owner said the card's not detecting, let's check the data lines. Third and fourth pin to the right, I expect to see similar values, which I do. Same thing on the back, measuring after capacitors. Clock reference plus and minus measured at the slot, and they both look the same. Flip the probes and check PEX reset pin with the positive on the ground. There's also a fuse, so let's check that. Now let's power on the card and see what we have. It only draws 0.1 of an amp, which is suspiciously low, so let's look at the voltages and see what we're missing. We do have 12 volts everywhere. Then we have 5 volt. We don't have PEX, but we do have 1.8. 3.3 is also there. If we're missing PEX, we're likely missing core and memory as a result of that. For anyone who knows the order in which voltage rises on this video card will realize that I'm looking at the problem in the wrong area. And you are 100% correct. It was late, I was tired, and that's probably the best excuse I can give. But the good news is that because of this mistake, I was able to find a faulty component which later would need to be replaced anyway, so the outcome is the same even if the repair was done in the wrong order. In other words, for whatever reason I assumed that I would need to get PEX after memory, and since I had no voltage on memory, I started to look at it first. In any case, let's continue with this out of order repair and see if we have enable signal going to the memory phase controller. Enable signal is on 36 pin, and there's nothing there. Let's follow the board view and see what component can be at fault. Pin 36 is connected to this 0 ohm resistor. Let's check and see if this resistor is broken by measuring the voltage before and after. Looks like nothing on either end, so I can assume it's fine. These two resistors do not exist on this card, so we can ignore them, but we do have this logical AND gate. In order for this to work, we have to have voltage on pin 1, 2, and 5. If we do, pin 4 will also have voltage. So let's look at it and see if we have voltage on pin 5 and 4. Five volt on pin 5 and 0 volt on pin 4. 3.3 on pin 1 and nothing on pin 2. That is why pin 4 has no voltage. In case this is confusing, the logical AND gate rises voltage on pin 4 only when both pins 1 and 2 have voltage on them. And the pin 5 is basically its power supply. So without voltage on pin 1 and 2, there will be nothing on pin number 4. Okay, so let's check for resistance on this 0 ohm resistor. The resistance we're getting comes from two places right now. First is the controller itself, and the second is the logical AND gate. One or the other is pulling it to the ground for some reason. The easiest diagnosis would be to remove this logical AND gate and see if resistance normalized. And that's exactly what I'm going to do. Now let's check the measurements on this pin, and we get 10 kilo ohms. Let's check other pads for any abnormal reading. 100K on pin 4, 4K on the first pin. So this U26 on the board has this part number. This is the same logical gate used for PEX reset, responsible for detecting your card. I have a few of those brand new, so let's put it in and see if it helps. Now let's check for resistances one more time, and we have 9 kilo ohms on pin 2, so the short was fixed by replacing this logical AND gate. But once I powered the card, nothing happened. We still have no PEX, and that brings me back to my mistake looking for a problem in the wrong order. We first have to fix the problem with no voltage on the core, so let's do that. Core phase controller is on the back, so let's take a look at it up close. Looks identical to the other controller, so everything else is more or less the same. This time I will be looking at the pin number 38. Pin 38 is a power good signal that enables PEX. This pin is also connected to this pad, so I will be measuring it from this pad, and I have nothing on there, and that explains why we have no PEX. Let's take one step back and see if we have enable signal on this controller. Enable signal is what turns this controller on, and it's on pin 36. We don't have enable signal, and that's where I normally end my recording because repair starts to get very chaotic at this point, but that's okay. This time I decided to keep recording so that you and I can learn something. Also, a special thanks to Tech Cemetery, who guided me in the right direction making this video possible. He's a true goat of GPU repairs, and I'll link his channel in my description so you can go check him out. In any case, I am backtracking enable signal to the front of the board, and I landed on Q31. Here it is. Enable signal should be on this pad, but there is nothing. So next in line is anything that's directly connected to this pad. This resistor here is 0 ohms, and this resistor here should be 10 kilo ohms. But if we measure it, it's short. It's not the resistor that's short. I already checked it. Instead, what happens is, if the 5th pin has no voltage, then the 6th pin stays grounded. In other words, Q31 transistor is shorting the signal to ground by default, and opens the short only if circuitry that exists before this transistor works as expected. We can confirm this by removing this transistor and measuring the 6th pad again, and we have 2.4 volts as expected. So now you're asking yourself, if you remove the transistor, where does the enable signal come from? The 2.4 volts. The answer is, this phase controller actually generates its own enable signal. Then this signal gets grounded by this transistor, thus making it read 0 volt. This means the problem is before this transistor. More specifically, according to the board view, pin 5 goes to this resistor, which we do not have on the board. But it also goes to the other side of the board, to this area here. This here is supposed to be 0 ohm resistor, so let's check and see if it's blown. And it looks good. Backtracking further, it goes through this diode, so let's check this diode. It should have voltage drop one way, but not the other. No voltage drop this way, and there is some voltage drop the other way. So after this diode, I hit a roadblock. There's no more components to go through, which makes no sense. Now take a close look at these pads here. They look fine to me, but now let's take a look at the pads below. And you and I both realize that these pads below are smooth, and I'm guessing we have two logical AND gates that were ripped nice and clean. And that's why I wasn't able to see it at first. So without wasting any more of your time, I took those from a donor card donated by a viewer like you. Thank you. And solder them on. Now let's check and see if we get voltage on this diode. And we get 3.3 volt before and 2.7 volt after. 2.7 volt before this 0 ohm resistor and 2.7 volt after. Now let's track forward. Pin 5, where we previously had nothing, and now we have 2.7 volt there, which means that we have 6 pin is no longer shorted to ground, which means the enable signal, which is generated by the controller itself, is now good. Which means we now have voltage on memory and core and obviously PEX. Okay, next step is as usual, power up the card and see if we get a picture or not. It looks like we have a picture, and now it's time to assemble the card and run some tests. Unfortunately, the owner of this card did not supply every screw I needed. I only have 3 screws for the core, which is very bad because it will make contact with the core uneven, resulting in higher temperature differences between the core and hotspot, as you will see. It also means I will not be able to fully stress test the card due to risk of overheating. You can see that after running it for a few minutes, it already shows 18 degrees of difference. So I ended up quickly running a few seconds of heaven, just to make sure it does not artifact, which it does not. And I guess we're done here. I'm sorry if this video has gotten a little bit long and maybe convoluted at times, but it is what it is. I'm sure there was some helpful information here and there that you were able to pick up along the way. With that said, this is it for this repair. And if you guys are interested to know about the equipment and supplies I use for my repairs, I now have links in the description, so you can go ahead and check them out and buy if you like. And as usual, thank you for watching and have a blessed day, and goodbye.